Hello dear learners, welcome in Tesla tutorial. Dear learners, once again I am here with you all with another interesting video where we will solve some numerical problems on the topic telescope. So without any delay, let's take very first numerical on the topic telescope. So the first numerical is a small telescope has an objective lens of focal length 140 centimeters. So here we mentioned FO equals 140 centimeter and an eyepiece of focal length 5 centimeter. Okay, fine. What is the magnifying power of the telescope for distant object? When first case is the telescope is normal adjustment. In the previous video I explained about these two conditions, normal adjustment and when final image is at the distance of distinct vision. There you saw that when the telescope is in normal adjustment, in that case final image is formed at infinity, and when final image is at infinity, then angular magnification or magnifying power capital M of the telescope is simply defined as the ratio of FO over FE, means ratio of the focal length of the objective to the focal length of the eyepiece. Thus angular magnification capital M is equals 140 over 5. If we are solving this, then we are going to get actually 28. So the magnification is 28 in first case. If we are talking about the second case, here I am mentioning in first case. If we are talking about the second case B, where the final image is at least distance of distinct vision, in that case simply we write angular magnification or magnifying power of the telescope is FO over FE 1 plus FE over D. In this expression, all these quantities means FO, FE and D are in its magnitude form, means only the distances are these, nothing else, means these are not coordinates, means these are not with their sign convention, only magnitude of these quantities are mentioned. Therefore, putting the values of FO, FE and D from the given question, we will get the answer as FO we have 140, FE we have 5, 1 plus FE means 5 and D least distance of distinct vision, it is of 25 centimeter. So if we are solving it, then 140 upon 5 is 28, and if we are solving this fraction, then we are going to get 6 over 5, and if we are dividing the whole, then we are going to get 33.6. So in the normal adjustment, magnification is of 28, and in the case when final image is at least a distance of distinct vision, that is at 25 centimeter away from the eyepiece, in that case magnification is of 33.6. Let's take another problem of another kind. So here the second problem is a telescope has an objective of focal length 140. The same question is of a very first part, 140 centimeter and eyepiece of focal length 5 centimeter. Fine. What is the separation between the objective lens and eyepiece lens? So I told you length of the telescope, which is the separation between objective lens and eyepiece lens, is simply the sum of focal length of objective and focal length of eyepiece. So length of the telescope L, or you simply can say separation between objective and eyepiece is equals FO plus FE. FO is 140 centimeter and FE is 5 centimeter. In this way we are having the separation between these two quantities 145 centimeter. This is A part. Now let's take B part of the question. In the B part, if the telescope is used to view a 100-meter tall tower 3 km away, what is the height of the image of the tower formed by the objective? Here we are not talking about whole telescope, only we are talking about, only we are concerned about the objective of the telescope. So here the things given to us: focal length of the objective FO, which is 140 centimeter. Next thing we have to give in length of the object. So length of the object I am writing here, O means height of the object with respect to objective, O small o, which is 100-meter tall. And the distance, if you're talking about the distance, so you are writing U0 means distance of object from the objective, U0, which is 3 kilometer, means 3000 meter. Now you have to find the magnification or the height of the image, IO, with respect to objective, means height of the image with respect to objective we have to obtain. So simply we can obtain this IO in a very easy fashion by considering angle subtended by the object situated at infinity to the objective, that is alpha. If you can remember, then alpha is simply defined as the height of the image. Alpha is defined as height of image, means with respect to objective, IO upon, and this image was formed, means objective was forming image at its focal length, so FO this was. So in this way, if we have to get IO means height of the image formed by objective, IO, then simply we have to get alpha times FO. FO is known to us, which is 140 centimeter, but alpha is not known to us. So say this is equation 1. Now try to get alpha in another way. If we find alpha, if we think about alpha, then simply we can say alpha is the angle subtended by the far distant object at the objective. So in this way we can say angle alpha subtended by a far distant object, simply arc length upon radius. So arc length will be equal, in this way we can write. So alpha we can write arc length upon radius, if we are using this definition also करके we can write. So here we can write alpha equals arc length upon radius. Here arc length will be the height of the object. So height of the object is the height of the tower, which is 100, upon radius. Radius means distance of the tower from the objective. Distance of the tower from the objective is 3000. So in this way we are having alpha equals 1 upon 30. Thus if we use the value of alpha in first equation, then we are going to get IO equals 1 upon 30 times FO, which is 140, So we are going to get this. So if we are solving this, then we are going to get 14/3, which is nearly equal, which is equals to 4.7 centimeter. So height of the image formed by objective is 4.7 centimeter with respect to the height of the tower, which is of 100 meter tall in front of objective at a distance of 3 kilometer. So this is the second question. Now let's take third part of the question. Third means C, part C of the question. Part C of question asks to us, what is the height of the final image of the tower if it is formed at 25 centimeter? For getting the height of the final image, let's first find the magnification produced by eyepiece. If you are getting the magnification produced by eyepiece, then simply it will be the ratio of the height of image to the height of object with respect to the eyepiece. So height of the object actually known to us, which is height of the image formed by objective. So height means image formed by objective acts as object for the eyepiece. So whatever is the height of the image In case of objective, that is the height of the object for the eyepiece. So in this way, height of the object with respect to eyepiece is known to us. Height of the image will be known if we are getting the magnification produced by eyepiece. Magnification produced by eyepiece, ME, equals 1 plus D over FE. So if we are writing we are replacing the values of D and FE in this expression, then simply we can have 1 plus 25 over 5, which is equals 6. Thus in this way we are getting magnification produced by eyepiece equals 6. Magnification produced by eyepiece also can be written as the ratio of the height of image to the height of object. So height of image means height of the final image, height of object means height of the image formed by objective, that is IO. So in this way, if we are multiplying, we are solving this, then we can write height of the eyepiece, height of the image formed by eyepiece, that is final image, equals I. Also we can write, that is final image, height of the final image equals IO times 6. So IO, a little bit earlier we got 14 over 3 into 6. So if we are solving it, 3 1 ja 3, 3 2 ja 6, and 14 2 ja 28. So in this way, the height of final image is of 28 centimeter. Once again, watch the whole solution of this question and try to get the concepts involved to solve this question. And after getting the concepts involved in that, take this question, pause the video, note down this question in your copy, get the solution of the question, and comment the answer of the question in the comment box of the video. Thank you.